Alright, so today talking about block diagrams, so and how to simplify them, mainly because sometimes you'll end up with a really complicated block diagram. Well, maybe you have your R of S comes into a summing junction, and then you have another one, and then another one, and this one comes back here, maybe this one comes and loops up, and maybe there's a transfer function right here, or a plant, and then you have a sum over here of this, and it can just get needlessly complicated as you go along. So there's two basic ways of simplifying these. And the first has to do with what is called a pick-off point. So let's say you have your R of S, and your R of S enters the system, and it immediately branches off. So that's called a pick-off point right there. And then you'll probably have something like G1 of S, G2 of S, and G3 of S. Just like that. And at this point, what happens here? Now, let's say this is just C of S. All this is G1 of S plus G2 of S plus G3 of S. It's kind of like capacitors in a way, if you want to think about it as a circuit analogy. If the capacitors are in parallel, you can just add their capacitances up. And can't really think of an analogy for if all of these are just in cascade form. At that point, you just multiply all the transfer functions together. So that's one way of simplifying. It's R of S. That's C of S. And then the other thing that can happen, and I just mentioned it, is when you have cascade form. So that was parallel form. And this is cascade form, where you'll just have G1 of S, G2 of S, and C of S. R of S is your input. And this just boils down to G1 of S times G2 of S. Equivalent to. So those are two pretty basic but pretty useful tools that you can use to simplify your block diagrams. And something else that you can do to fool around with the block diagram, let's say you have your R of S that comes in, and it reaches a plant, G1 of S, and that goes to a junction, and X of S is right here. Now your output here would be RS G1 of S plus X of S. Another thing you could do, if you wanted to simplify this, maybe trying to seek unity gain in the feedback loop, so you could find the closed loop transfer function. What you can do is this is equivalent to your R of S coming in to the summing junction, and here you multiply by 1 over G1 of S. And over here, you multiply by G1 of S. And that's your output. So you can fool around, and as long as the answer comes out the same, you can modify your block diagram in order to obtain that unity gain in the feedback loop so that it's easier to find the closed loop transfer function. And this can be applied to block diagrams that span on for, like, you can take up this whole board, but you can eventually sum it up in one transfer function. It's like a black box, so you should be able to sum it up into one transfer function. So that's the simplification of block diagrams.